Rachel. Right, well, if you're all sitting comfortably, welcome all to another Hertfordshire Building Control CPD event. For those who don't know, I'm Trevor Clements, Head of Business Development. Hope it all goes well today. We've got a big audience. If you lose connection, then just go back to the link, click the link again, and you'll be let back in again without any problems. But hopefully you'll be able to stay with us. So today, as I said a bit earlier, it's not me rambling on, and we've not got any companies in to talk to us. We've got one of our own district surveyors presenting, and that's on the subject of ventilation in buildings. He's our Assistant District Surveyor, Tom Casson. And the idea for this event came about when Tom was good enough to show me his dissertation that he did for his university qualification. And to be honest, I was very impressed with it and found it very interesting. So from then on, we thought, well, yeah, maybe we could put this together as a presentation for our colleagues and customers. It's come at a good time because as part of the Future Homes Standard, we're expecting a new Part F of the building regulations and a new Part L, and draft approved documents are under consultation. They're a bit late coming, but we're expecting them any day now, and I know Tom's going to touch on those. You know, it's a Part F, there it is. It's a very flimsy document, isn't it? And, you know, a lot of people, well, I certainly myself included, used to think, well, it's not really very important when you think of, on the grand scale of the building regs requirements, you know, it's just not one to get too excited about. Well, strap in and let's hear what Tom's got to say today, because I think coming out of this presentation, you might form a different view to that. But anyway, Tom, I won't carry on any further. I'll just hand over to you to take it away.
Well, thanks very much, Trevor. Hopefully everyone can hear me. My screen, the box has gone yellow, so hopefully that's the case. So just put my screen there and then, right. Okay, someone let me know if I can't see that. But yeah, hello everyone, and welcome along to this presentation on natural ventilation. And as Trevor said, yeah, my name is Tom Casson, surveyor for Hertfordshire Building Control. So in today's session, in the first half, I'm going to be talking to you about ventilation in general, its definition, what it is, its needs, and what its aims are. And then we're going to be exploring natural ventilation and how that occurs in buildings, and sort of talk more specifically about dwellings as we go on. In the second half of the session, I'm going to be looking at where natural ventilation fits into the building regulations and approved document F, and the development of the approved document itself. What can you expect from future changes that are coming, as Trevor said, from the recent consultation. I'll then conclude by sort of evaluating and giving my thoughts on ventilation use in English dwellings. There'll be an opportunity for questions at the end. So I think what we said just before is if you've got a question, store it up, and then at the end, put it into the chat, and I'll try my best to answer it for you. Okay, so without further ado, what I found doing my dissertation was that the best place to start when I was thinking about this subject was to look at its definitions. So ventilation in general could be defined as the movement of fresh air around a closed space or system that does this.
Tom, can I just interrupt you there? Are you running your slides yet? Because I don't think we're seeing slides at the moment.
Oh,
I think you've shared screen yet.
Oh, okay.
And that's a lovely first slide. We wouldn't want to miss it.
Oh, okay. Sorry. Hang on a sec. It's all going so well in the run through.
No, you're sorted. We're
there? Sorry, everyone.
No problem at all.
I'll start that again. There you go. Right. Right. Hang on. I'm just going to just going to move that out of the way because that's in my notes section. Yeah. So sorry. Yeah. As I say, that's our session roadmap. And just to repeat, yeah, sort of going through ventilation, then natural ventilation, approved document F, current practices, research, future changes and evaluation. As I say, questions at the end, if you don't mind. So, make sure that's working. Is that going to do that for me? Yeah, so, as I was saying, the definitions. Ventilation in general could be defined as the movement of fresh air around a closed space or a system that does this. Could be also defined as the designed supply and removal of air to and from a treated space. So what I got from that was that it's telling us that ventilation is about air movement within a space and that can be designed or manipulated into a system. So why do we need ventilation and what are the aims of ventilation systems? Well, in its simplest forms, ventilation is needed because it's an exchange of air. It's the removal of stale air and exchanging that with fresh air. And what I wanted to draw your attention to, first of all, was the fact that ventilation is a continual and live process. It's always happening. Even in buildings that have got wholly mechanical systems, we're always going to have a bit of air leakage, and because of the air outside and inside, that's always going to be happening. So that's the first thing to say about that. Ventilation is also there because of the fact that we need oxygen to breathe. And through the process of doing that, we create carbon dioxide, and that needs to be removed as well, because a build-up of carbon dioxide is also not good for us. Further aim or need of ventilation is the prevention of condensation and the accumulation of water vapor or moisture in the internal air. Now, this is detrimental to health because too much water vapor or condensation in the air is detrimental for people with asthma, and also too much condensation in the building itself can lead to interstitial condensation, and that can harm the building itself. So ventilation system will dilute and get rid of that. A further aim is occupant thermal comfort. Now, this might be a new phrase to most of you, but this is essentially defined as that condition of mind which expresses satisfaction with the thermal environment. And essentially, this is the individual within the building either feeling too hot or too cold. But because it's such an individual experience and with many people in the building, it's quite a complex subject, and we could spend a whole session on that itself. So it is quite a complicated area, but is an essential aim of ventilation. Could we say that ventilation is key to preventing COVID? Well, there's certainly a growing body of evidence to suggest that COVID transmission is now by aerosol. In the early stages of the pandemic, we were told that the main way that the virus was going to be transmitted was through heavier droplets and particles from coughing and sneezing, and then sort of touching surfaces, and that was the main transmission. But there is a growing body of evidence to suggest that virus particles can stay in the air for longer periods than previously thought. And that's why the government are providing us with yet more slogans to tell us to take care and refresh our air and increase the amount of ventilation that we get into our dwellings so that we can potentially remove those virus particles. Another one of the key aims of ventilation is to remove a wide range of gases, odours, pollutants, vapours and particles that are now present in the internal environment. And this could be down or due to the fact that there's been an increase in the diversity of materials and products that are used in construction and that are brought into the internal environment. And this graphic here is showing you all of the places where there's possible ways that these particles and pollutants can get into our home, right the way through from obviously fumes coming from the car through to most of the house in various different ways that can happen. And you might be asking yourself, well, how do these particles make it into the air? Well, it happens through a process called off-gassing. And essentially, this is organic compounds or chemicals that are used in the materials that vaporize. And so they basically become in a gas at normal room temperature and pressure. So a way to imagine this is if you've just walked into a room that's been freshly painted, it's going to have a distinctive smell to it. And that is essentially the chemicals or the products that are used within that paint vaporizing and becoming part of the internal environment. And you're then going on to smell that. So that is essentially these products making it into the internal environment. And the reason we want to dilute these products and remove them away is because of their associated health risks. Now, I'm not going to go through every single point here on this table, but essentially what I was going to draw your attention to was really the box that's highlighted in the middle, and volatile organic compounds. And these are a broad range of chemicals present in a wide variety of products. Now, the two big ones within this are formaldehyde and benzene, because of their potential carcinogenic associated health risk. But they're found, as you can see there, in a wide range of products, you know, from paints, white spirits, glues, cleaning agents, air fresheners. All of these volatile organic compounds are making it into products. Obviously, above and below, there's some of the more common ones that we already know about, and obviously their associated health risks. So the general descriptor that we would use relating to the prevalence of those factors or hazards in the internal environment is indoor air quality. Do we have good or do we have bad indoor air quality? And despite knowing the hazards of these volatile organic compounds and particles that are in the air, many researchers, you know, do lament the lack of research into the long-term effects of poor indoor air quality, and our understanding in the area does continue to evolve. And there is prescriptive guidance coming out on volatile organic compounds for the UK, and that's coming soon. But it's essentially accepted that the ventilation strategy should maintain good indoor air quality and effectively dilute and remove these potential hazards. So to wrap up this section, the ultimate goal of a ventilation system, therefore, is to achieve the simultaneous balance between its various aims. And as I've sort of spent a few minutes explaining, that's not an easy feat for, you know, one system to do. So what about natural ventilation? Well, again, going back to its definitions, I mean, which I'll come on to, but essentially it's not a mechanical system. Mechanical ventilation is powered fans and control systems that are used in a building to forcibly supply and remove or condition the air in the space. Natural ventilation can be defined as a ventilation system which relies on pressure differences without the aid of powered air movement components. It can also be described as the flow of air through a building resulting from the provision of purpose-made openings such as openable windows, ducts, shafts, etc. The flow of air is driven by naturally occurring phenomenon such as wind blowing on the surfaces of a building or air density differences caused by temperature variations. So how does natural ventilation occur in buildings? Well, the last definition alludes to the answer to that question. There are two main ways in which natural ventilation occurs in buildings. The first is wind-driven natural ventilation, or more commonly known as cross ventilation, and the second is temperature-driven, or more commonly known as the stack effect. So, regarding cross ventilation, the movement of air occurs through openings in the structure when wind acts upon it, and as air enters the building on one side, it leaves the building on opposing sides. It can also happen through positive and negative pressures of the wind on the property, and as it moves, the negative pressures draw out the air through cracks or openings in the building. The second, natural ventilation also occurs through temperature differences in the internal and external space, and it's a process that's known as the stack effect, which is basically the vertical movement of air in a building induced by density differences in the enclosed space and the ambient temperature. But put simply, it's the fact that warm air rises, as we know. And we can basically assume that as it does that, it will draw in fresh air at a lower level, and essentially that air is replaced in the building. So just as a quick recap, we've got our aims of ventilation systems, the supply and removal of air, getting good indoor air quality, achieving thermal comfort, moisture removal and breathing. From that, we want And we could use natural ventilation to do that. And that principally occurs through cross ventilation or via the stack effect. So how do we design for that to occur in a building? Because if we're able to do that, then we're going to be able to achieve the aims of a ventilation system. So designing for natural ventilation in buildings utilizes the principles of cross and stack ventilation to encourage a rate of air supply and removal. This is known as the ventilation rate. A space with a high ventilation rate is going to be energy inefficient and drafty, whereas a space with a low ventilation rate will have poor indoor air quality, which is detrimental to health and can harm the building. So an adequate ventilation rate is required to exclude both of these negative consequences while still achieving the aims of ventilation. Ventilation rates are measured volumetrically, and the units of measurement are, in the literature, are given as either meters cubed per hour or litres per second. And the rate is determined by tracking the supply and removal of air in the building over a given time period. Now, personally, I prefer to think about this, or when I imagine it in my head, I think about meters cubed because I can just see that easier. But essentially, you're looking at, sort of air changes and that ventilation rate over an hour. So if one was to imagine a room or a space, in this instance, we've got a room that's 4 meters by 4 meters and 4 meters tall. So we'd have a space that is 64 meters cubed. So if we're going to be talking about a ventilation rate of 0.5 air changes, we'd be talking about that over the course of an hour, 32 meters cubed would have to be removed and replaced with fresh air. And that graphic shows that the white boxes would be our fresh air coming into the space. So essentially, this would then be given a ventilation rate of 0.5 H, or air changes over an hour. Or for those that prefer to think about it in a different way, this would be 8.8 litres a second. So the components of natural ventilation design that determine the ventilation rate. Well, quite simply, the first one is going to be our windows. If the windows are closed, the ventilation rate is lower. If they're open, it's going to be higher because we've got that space for the air to come in and move. Now, the layout is quite important as well because the forces that drive natural ventilation are actually quite weak. And so partitions in a space will effectively drive down that ventilation rate and lessen its occurrence. So open plan layouts are going to be easier for natural ventilation to occur and the ventilation rate will be higher. But one way that we can sort of overcome that or facilitate it is to provide gaps underneath doors or in the partitions themselves, but underneath doors as well, that can basically facilitate the ventilation rate. And the last one, which we're going to talk about quite a lot, is our good old friend, the trickle ventilator. So for those that don't know, a trickle ventilator is a device which allows the continual exchange of air in a building. It consists of a row of slots or holes which provide controlled, what the building regulations called background ventilation, and they're usually positioned in window frames. And these are usually positioned about 1.75 meters above the floor level as well. And I'll go on to talk about these a little bit more, but trickle ventilators are the principal method of achieving the desired ventilation rate in modern buildings. There is, however, a fifth member to this band, and that is infiltration. Infiltration is the uncontrolled or undesired exchange of air that occurs through cracks or air leakage paths in the building fabric. Infiltration is undesirable because if air is easily transferred out, then so too is heat, resulting in wasted energy. So infiltration was reported to be accountable for 40% of heat losses in buildings in 2000. So as a result, the focus in house building over the past 20 years is to be has been to effectively improve energy efficiency by driving down infiltration, most significantly in 2006, when there was a requirement in Part L to increase levels of air tightness built into the fabric of the building. And so consequently, when you do that, you have to then provide purposeful and designed ventilation to replace it. And effectively, this takes the form of trickle ventilators to provide and achieve that desired ventilation rate. So that's our sort of first half of the session done. And now I'm going to go on to talk about the development of approved document F. So where does an approved document come from? Well, usually legislation, policy and guidance. And before there was an approved document, there was a British standard. And when we're looking to understand how to design something, mostly the first protocol is going to be our British standard for the document. In this case, it's BS 5925, the Code of Practice for Design Buildings, Ventilation Principles, Designing Natural Ventilation. First one came out in 1980, was amended in 1991, but remains current today. It's a comprehensive, detailed and scientific document covering the area. I know it took me like a weekend to read through. And the key components of natural ventilation are identified and illustrated thoroughly in this document. It is quite complex, and the length of it makes understanding natural ventilation fully difficult. And so therefore, it's not particularly used, I would say. And of course, significant changes affecting natural ventilation in buildings have taken place since 1991. And so the information within it is outdated. But drawn from that, the approved document comes. And an approved document is issued by the government as a way of illustrating compliance with the building regulation requirement. It's not the only way, it's just a way of complying with it. But when it comes out, first of all, it's quite simple and the information in it is limited. There's no explanation of the science behind the requirement or the reason why, just showing you how to comply. And the main focus of this document throughout has been the prevention of the accumulation of moisture or water vapor in the internal air. So that's what it's looking to do. So the first one comes out in 1985. Its approach is on moisture. Habitable rooms have to have an opening area equal to 1/20th of the size of the floor area of the room that it's in. And the alternative is a mechanical system. But at this point, it's an either-or approach, one or the other. In 1992, the amendment comes out to the approved document, and its approach is again on moisture, sort of limiting that, but highlights at this point that the occupant should retain the control of their ventilation provision. It also introduces at this point the interaction between natural ventilation and having intermittent extract to wet rooms, and also introduces us to trickle ventilators or providing background ventilation. But there's no requirement for a specific amount of area to that trickle ventilation. In 1995 and the 2000 amendment, there's no significant change, except there's greater detail on trickle ventilation provision, i.e. that in each room you've got to provide 4,000 millimeters squared in area, and the position has to be 1.75 above the floor level. Now in 2006, we do get the most significant changes to the approved document. The approach is still on water vapor removal because they've now changed it and called it water vapor instead of moisture. But they've also recognised that there are the VOCs that are potentially in the internal environment that I talked about earlier on, because there was some research done by the BRE and they've recognised that this is now something that needs to be diluted. And as a result, you get a greater scientific explanation and the interaction between Part F and Part L. And Part F introduces a whole dwelling ventilation rate. And this is essentially what I was talking about before, a designed ventilation rate in response to a target infiltration rate in Part L, which is essentially that infiltration rate should be less than 10 meters cubed per hour at 50 pascals of pressure. We also get introduced to the 4 systems approach to compliance. And I'll talk about natural ventilation more in detail, but essentially the natural ventilation approach is system 1. And the others are passive stack ventilation, system 2, system 3, continuous mechanical extract, and system 4 is mechanical extract and supply. Again, a theme that remains throughout is that the occupant should retain their control over their ventilation provision. So they should be able to shut trickle ventilators if they so desire. At this point, we get introduced to the provision that we should have 10mm gaps under the doors, and the designer is encouraged but not required to consider the dwelling's position in relation to external pollution. And this is important because I'll speak about this later on. Trickle vents are required. Oh yeah, I was going to bring your attention to this because trickle ventilators are required on replacement glazing at this point. So anybody who, even in an existing dwelling, replaces their glazing at that point or that year had to provide trickle ventilators. But a year later on, they decided to replace that requirement from that it should happen to that it's good practice. And I'm yet to find out why, but in my opinion, if that hadn't happened, we would have better ventilation in our dwellings. In 2010, there's no significant change to the 2006 document, except that if the infiltration rate is less than 5 meters cubed per hour, then you basically have to provide more trickle ventilation or the equivalent area. They also separate quite a lot of the information that was in the 2006 document and put it into a separate document called the Domestic Ventilation Compliance Guide. They also introduced Regulation 39, which is the requirement to give information to the eventual owner of a property. You've got to give them that information about their ventilation system, but it's only required on mechanical systems. So basically system 4, system 3. So in summary, what we can say about the approved document is that it starts simple, but it does get more complicated as time goes on. The main focus throughout pretty much has been the prevention of water vapour accumulation. It's not been on the other aims that I sort of talked about in terms of the occupant thermal comfort side to things. Initially, natural ventilation is just provided through an openable window, but this quickly gets replaced with additional help. Supplementary mechanical ventilation is required in vapour-producing rooms to extract the moisture-laden air at the point of production. So when you're cooking or showering, get rid of most of the moisture, and then the natural ventilation provision will get rid of the rest over time. Background ventilation in the form of trickle ventilators is brought in to facilitate the ventilation rate and the dilution of excess water vapour and contaminants. There is, as time goes on, greater interaction between Part F and L, as the main focus in house building has been on limiting infiltration as a way of energy conservation. And latterly, as I said, they've brought in the sort of explanation of volatile organic compounds. And at that point, they're asking the designer to consider the location of vents for external pollution, but this is tucked away in an appendix at the back, so could be forgiven for missing it. Occupants retain the control over their ventilation provision throughout, and they can override the provision if desired. And they're only informed about their ventilation provision if they're provided with a wholly mechanical system. So where are we today? What is the current practice? Well, in terms of natural ventilation, approved document F, it's system 1. And this is essentially, as I've been saying, openable windows equal to 1/20th of the floor area. The trickle ventilators are there to provide you with the ventilation rate, but natural ventilation isn't enough on its own. You need some intermittent extract there to get rid of the moisture in those moisture producing rooms. You're asked to provide 10mm undercuts to doors to facilitate the movement of air around the property. So this is the most popular choice in residential property, 62% since 2006. But since 2010, the requirement has been to base the total equivalent area of trickle ventilators, which is measured in millimetres squared, on the proposed infiltration rate, or air permeability, as it's called in the approved document. And that sort of proposed infiltration rate for your new dwelling is produced by the SAP calculation and should be under 10 metres cubed per hour at 50 pascals. And then there are tables in the approved document to help you with that, and you look at what the floor area is of the property, how many bedrooms it's got. And then, as I said before, since 2010, if you've got quite an airtight building, so less than 5 metres cubed per hour, you just have to provide more trickle ventilation. So what has been found in terms of how well natural ventilation works in our current properties? In 2010, the UK government did some research into the English housing stock. They basically found that 72% of the natural ventilated dwellings did not have sufficient trickle ventilator provision. 52% did not have the recommended 10mm door undercut. And although the levels of formaldehyde were acceptable, the overall, in half of the properties, they had excessive levels of volatile organic compounds. And the conclusion was, let's increase the ventilation rate and provide more trickle ventilators. Now, although obviously we're not looking at English housing stock here, this is an important study because Scottish regulations are quite similar. But in 2014, the Scottish Government research found that in their properties, there is a lower than adequate ventilation rate, even with trickle ventilators fully open. Trickle ventilators are frequently out of reach and blocked by curtains and blinds, and when they went in to inspect, most of them were closed. Again, door undercuts are blocked by the floor coverings. And one thing I wanted to draw your attention to at this point was that in this particular research, they focused on measuring carbon dioxide levels. Now, this is important because carbon dioxide can be used as an indicator of poor indoor air quality. And when carbon dioxide levels are high, it's probable that volatile organic compound levels are also going to be high because they increase in linear fashion. And in 2019, we were presented with some research, again, from English housing stock from houses constructed after the 2010 changes. And in 50% of the dwellings with natural ventilation, they didn't have sufficient trickle ventilator provision. And again, most of these were occluded by curtains and blinds and closed on inspection. In 60% of the sample, carbon dioxide levels and volatile organic compound levels were above the recommendation. Interestingly, what they also found was that in the English housing stock, there at the time was a significant risk of overheating. So most of this research is undertaken in the heating season during winter, because that's going to be mostly likely when people are keeping their windows closed or trickle ventilators. But you can also get an issue in the summer as well with overheating, because again, the same thing is happening. There's not enough of a ventilation rate to make the indoor air quality good enough for people in the summer. So that was a problem for them. So essentially the conclusion was that they've started to recognize these issues with this research that had come out, and that they needed some change. So in September, I think it was 2019, we got a consultation for changes to approved document F and L. And I'm basically going to go through those changes or what's proposed in the draft approved document F. So they're looking to simplify the approach, but it's essentially more of the same. Increase the trickle ventilation to increase the whole house ventilation rate. The minimum whole house ventilation rate or dwelling ventilation rate will be increased. And trickle ventilator equivalent area will be based on the room type. So rather than at the moment, you look at the overall floor area of the building and how many bedrooms it's got, and then decide how much trickle ventilators equivalent area you require. Now it's just a simpler approach. What type of room is it? And this is how much you need. So in system 1, which is the natural ventilation, this will only be applicable for proposed dwellings which are deemed to be, how the document describes, less airtight. So this is essentially if the infiltration rate is greater than 5 meters cubed per hour at 50 pascals. If this is the case, then the trickle ventilation will be based on the room type, as I said. In a 2-story house, you'll need to provide 10,000 millimeters squared for a habitable room and 5,000 millimeters squared background ventilation for kitchens and bathrooms. In a 1-story house, habitable rooms will have to have 12,000 and 8,000 for kitchens and 5,000 for bathrooms. If any bathroom in the dwelling doesn't have a window, then you have to increase the trickle ventilation provision to 12,000 in the habitable rooms to compensate. And a note to anyone who's involved in designing flats or looking at flats, natural ventilation will not be allowable on dwellings with a single exposed facade, or if 70% of the openings are on one facade. And this is essentially because you can't get cross ventilation going with flats. So that's one thing to note on flats. System 2, basically they found in their research that no one's using it, so they've scrapped it as a system. And you'll find that there'll be the promotion of continuous mechanical extract, which is the current system 3. And this will have to be used on dwellings that are deemed to be highly airtight, i.e. the infiltration rate at design stage is less than 5 meters cubed per hour. If that's the case, then the trickle ventilators don't need to be provided in wet rooms, and in habitable rooms, it's 5,000 millimeters squared. So essentially, you'd be designing a system where you've got the continuous flow of air throughout the day. And of course, system 4 is retained because this is a continuous supply and mechanical extract system. I said earlier on that there was a part in an appendix of the current document devoted to minimizing the ingress of external pollution. And this has been promoted now to be given its own section. So it's going to be, you're being encouraged to really think about where the dwelling is, what its position is. And I say that it's mostly on commercial because that's how it's worded, but perhaps have a think about going forward the position of your dwelling. If you're designing for that, if it's next to a main road, it's possible that we could be thinking of better ways to ventilate than natural ventilation with the trickle ventilators on the side of by the road. And there will be the promotion of testing and commissioning of all ventilation systems. So at the moment, it's only required on mechanical systems, but building control will be required to be given or complete themselves a commissioning checklist and commissioning sheet for all dwellings that details the requirements are met, including system 1, natural ventilation, on top of the existing requirement for mechanical installation. So building control officers will have to be given, or will go around themselves and note whether a dwelling complies. Has it got enough background ventilation, trickle ventilation, what the floor area of the dwelling is, and have to retain that on file. So it's important that this is done, and building control will be looking for this on completion. Again, and that information will now have to be given to owners and future occupants, including on system 1. So look for some literature that explains perhaps what trickle ventilators are, and because that will have to be provided to future occupants of the building, and not just on mechanical installations. So, almost at the end now. What are my thoughts on this? Well, we've known about the fact that if you build a property tight, then you've got to ventilate right. And the research back in 1989 by the BRE did say this. And they said that occupants needed to be given information about their ventilation system on mechanical and natural ventilation systems at that time. And as a result of that, the house building sector has focused on reducing infiltration rates due to energy conservation, but it has resulted in poor ventilation rates, as the research has shown. With that lack of information given to occupants who've got the natural ventilation system, this has made the problem worse. And the research has shown this. Thermal comfort is also a key aim of ventilation, but it's not dealt with adequately in the building regulations. In the research that I did for the dissertation, I showed that occupants will, in the absence of information, favour thermal comfort over good indoor air quality. And that's basically because they're thinking about the immediate effect of sort of opening a window and ventilating it and losing the heat, which is going to cost them, versus the long-term effects, which are less known, of having that poor indoor air quality. So it's not being dealt with particularly well in the building regulations at the moment. And the efficiency, the efficacy of natural ventilation is dependent on the design and the control of its comprising variables. But these variables are unpredictable. We're talking about something that's natural and outside of our control. We're talking about wind pressures, the internal and external temperatures, perhaps the building leakage, areas that haven't been built quite tight enough, the exposure of the building where it is. So is it in a city or is it in the countryside and exposed? Are there other buildings? This can affect the direction of prevailing winds and how much wind that property gets, and the building orientation, is it facing the prevailing wind or not, and the opening size and the location of the vents that are provided. All of this is too complex for approved document F, and approved document F simplifies things too much. But of course, ventilation is only one part of the overall design, and it can, you have to think about compromises when you're building something. So ventilation is often compromised in favour of other elements of the build. That said, the proposed changes to approved document F are positive, because natural ventilation is only going to be allowable on leakier sort of buildings. There'll be commissioning requirements, and the occupants are going to be provided with information about their ventilation system. So it's good. And for me, I feel that overall ventilation needs to continue its rise up the agenda in house building, because in 2018, it was estimated in England and Wales that 17,000 deaths occurred from respiratory diseases, and asthma cost the NHS £3 billion. And, how much of that is down to poor indoor air quality in our homes? The long-term effects of volatile organic compounds that are potentially in our homes at the moment, and is any of that preventable? Down to the ventilation system. Occupants retain the control throughout, and it's a good thing. You don't want to be necessarily having windows open all the time, but trickle ventilators can still be closed. So how do we ensure that compliance is ensured long term? One of the things that I've sort of noted as well is that in other building regulation compliance, that's fixed into the fabric of the building. When we think about the structure, that's there, and these things aren't particularly easily tampered with by the occupant, and have to do quite a lot to sort of affect the structure. And when we're looking, for compliance with fire, people aren't necessarily going to easily tamper with their smoke detectors, especially now with them being wired in. Things like drainage, it's all built into the fabric of the building as we go. But ventilation is a live and dynamic process, and it's ongoing. So, and that occupant thermal comfort and how they're feeling within the building is not adequately dealt with in the regulation, but that's an important aim of ventilation. So yeah, compliance with that ventilation provision can be tampered with post the building control involvement. But could there be a way for us to ensure compliance long term? Could we go further? Could we perhaps say that we could install some passive protection into the properties? Could we say that we install carbon dioxide alarms perhaps into properties, much like we do for, you know, smoke detection, or if someone's putting in a wood burning stove, we've got carbon monoxide alarms. Could we say the same for carbon dioxide? Because again, as I said before, this is an indicator of poor indoor air quality, and perhaps that could be an alert to the occupants that they need to improve their ventilation. So that brings an end to my presentation for today. Thanks very much, and yeah, just put it out there for some questions.
Excellent. Well, thank you very much indeed, Tom. That was really thought-provoking. We do have some questions. I'll fire at you if you don't mind. First one. Best. Yeah. Are you sitting comfortably? Star for 10. Francesca says, isn't there a conflict between having 10mm gaps under doors and the performance of fire doors? Well, that's a classic question we get asked, isn't it? I'll leave you to come back at that.
I don't know. That's not. Well, I mean, yeah, it is an area that we look at, but I mean, other building control surveyors may want to jump in at this point, but I don't think that it is, because in that situation we're looking at, you know, smoke filling up from the top down. So it's not a conflict in that respect.
No, I agree with that. I mean, fire attacks the door mainly in the upper part of the door, and as you say, smoke logging will occur top down, so fire doors can have that gap and still perform the function they're designed to do. But good question nevertheless. So another question, is it possible to specify products to greatly reduce VOCs? Well, yes, I guess the answer to that is yes. Triple vents also conflict with reducing heat loss. Yes, as you've mentioned, if the idea is to reduce VOCs, then if none are being used, why need more trickle vents? I think that's the question is referring to, why put more in the regulations. But I think that's the human factor, isn't it, that you've sort of mentioned? Yeah,
because VOCs are present in things that people are going to bring into the building themselves. You know, we can't control that through the building regulations. You know, they're present in, you know, anything, carpets, sorry, my God, blank, curtains, sofas, all of those fabrics that are brought in. You know, if someone decides to repaint in a certain way, building control has no involvement in that. So that the trickle ventilator is the passive protection, as it were, built into the fabric. But as I said before, you know, could we go further, because people have that control over those trickle ventilators? They can close them if they want, and you know, people put the blinds and curtains in front of them, which again disrupts their working and working adequately. So
we can only lead the horse to water, but we can't make it drink, is probably the phrase to use, isn't it? We make these buildings safe, but we can't always account for the human factor. But
I think the research has shown that, you know, fundamentally it's something that's just not happening. It's not working as intended at the moment. So.
A good observation from Ian Davies. Great to see you joined us, Ian. What about the current trend for putting, he says, SF doors in rooms? I think he possibly referred to big bifold doors in rooms with no separate casement windows. Is this enough to satisfy building regulations? It means you can only open the door to get decent ventilation, which is, of course, going to breach security. Interested in your thoughts on that, Tom?
I'd say, you know, you can still get the background ventilation in the form of trickle ventilators in a bifold door, but I do see what you mean. Well, the door is a provision for ventilation, and I don't think we can, as building control officers, go too much further than that, really, in terms of insisting that there's a casement window as well. That would be too onerous, I think. I don't know.
Yeah, we can't. Of course, it's a bit ironic. We've got Part Q, and we get all excited about the security of doors and windows, don't we, at ground floor level? I think Ian's point is well made, and we leave to good design, really. And yes, you know, it's good to have a casement window in as well as a door, because in the middle of winter you don't want to open your bifold doors up. But there, we leave that to you out there to take action. Mike says, would we be better off with smaller but permanently open trickle ventilators? Interesting thought.
I think so. But there's more than there are trickle ventilators out there that are based on pressure differences, and they're automatic. But I think, you know, that again, the research has shown that people just, you know, see them as an inconvenience, really. Or, you know, and also particularly, again, with the interaction of, you know, they do let in some noise. So people feel that they want to close them because of the noise effect as well, and the draft and yeah,
anybody who's got a wood-burning stove like me will know the irritation of having to have a permanent ventilator in a room, and that even for a professional, the temptation to block it up is great, but I must say I haven't. Thank you for that. Yeah, very good, Tom. From Richard, what are your thoughts on the provision of mechanical ventilation in lieu of passive ventilation, i.e. open all windows? How is this best achieved? Because Richard feels that the guidance is poor. Well,
I mean, it's not a system that we see too often in dwellings, at least. But I'm all for it, and feel that you know, with the changes that are coming in, where we've got that continuous mechanical ventilation, that, you know, we'll get better ventilation rates coming in. But I definitely would say that mechanical systems, you know, as much as I find natural ventilation quite interesting, is difficult for it to work effectively, consistently. Whereas, you know, mechanical system will do that for you. And that's ultimately why, you know, natural ventilation needs help in terms of those intermittent extract fans that are put in for your moisture accumulating sort of rooms, as it were. So, yeah, I'm all for it. Does that answer the question? Sorry.
I think that's a good answer. I'm just going to finish up with a few observations. There's lots more questions, and what we'll do is we'll take note of those. Rachel, I'm sure, is taking note, and maybe we'll when we put a round robin round to everybody, we'll answer those. But just a few observations. Noel O'Dowd says some fire doors are certified with gaps as little as 6 mil. Yeah, I wasn't aware of that, actually. It's a clash, isn't it? You know, because you know, if it is needed, does need a 10 mil gap to comply. In fact, a 20 mil gap if there's no floor covering down. There's definitely a clash of compliance there that we'd have to think about. Yeah, Mick says, thanks, Tom, really interesting. Feels like we've gone full circle. He lives in a 1937 property. Originally had 225 by 225 open vents in the wall in every room. And of course, they all got closed up to prevent thermal leakage. So, you know,
I definitely think there's a bit of, we've actually gone too far. We've made these buildings too airtight, you know, in the pursuit of energy conservation. You know, and there's nothing wrong in that, but, you know, the ventilation side of things has been sort of left behind a little bit, but hopefully it will, as I say, creep back up the agenda.
Yeah. And yeah, a few other people coming in on that 10 mil rule and pointing out, yeah, that some fire doors are needing this lesser gap, which maybe something we could look into and research, because we like to be able to give straight advice, and that's confusing. So great, there you go. As I did say, it was going to be good, and I hope everybody now agrees with me. Thank you very much indeed, Tom. Very well presented. And as I say, thought-provoking, because building control, I mentioned earlier, Part F is a very thin document. Of course, we get all excited about Part B, don't we? Look at this, that's a lot more weightier. Any of you building control people probably noticed that's the superseded version, which I promise I keep in a little bit better than refer to it. And of course, fire safety, rightly so, because over 300 people a year die in house fires. So we should take it seriously, and you know, not so many in commercial buildings, but even so. But as Tom said, you know, there's 17,000 deaths from respiratory illnesses, and not just deaths. There's lots of illnesses that we see that are linked to that, and it just makes you wonder how many of those could be prevented by better air quality. The research in 2019 was quite startling how few homes achieved those good air quality standards. Even compliant homes where they'd been built in a textbook fashion, they still weren't achieving air quality. So, you know, it makes me think maybe this little book, there's a bit more to it than we've given it credit. And when the new requirements come in, watch this space. We'll be doing some more presentations for all our clients to fill in the gaps and tell you exactly what came out of the mix. So that's us done. Another one under the belt. There's another one coming. Rachel, I don't know if you could. Do you remember the date for our next CPD presentation? It's rock wool, and I think it's relating to compartmentation and the use of mineral fibre products in that respect.
Yeah, that's the 10th of December. So another Thursday, same time, 3:30, 10th December.
Yeah, I hope you like the new timings. We did that on request of people who thought it was more conducive to the working day. Hope you'll be able to join us for the rock wall one. As always, any more questions come in resulting from this, just drop me or Tom a line and we'll happily answer those. But great to have your company, and safe journeys to all. Stay well, and see you again soon. Bye for now.
Thanks, everyone. Thanks for your comments. Cheers.